Hey, Kyle here with Maple Systems. Welcome to another Maple Systems video training series. Hey there, in this video I'm going to cover how to configure port settings and port priority to improve traffic management using a Maple Systems Lite Managed Network switch in the user interface, Maple Link Lite. So first, I want to explain why port settings matter in network management. You can control how each switch port behaves, and they're crucial because every device that connects to the network passes through a port. By tuning these settings, network admins can ensure compatibility and stability. So for example, you can manually set the speed, let's say 10 megabytes per second to 100 megabytes per second, or maybe 1000 megabytes per second. Also, you can set it to duplex mode, half or full, which prevents mismatches and drop connections. And I'll go over duplex mode in a little bit. It can also optimize performance. So using flow control, which I'll also go over, this avoids buffer overflows by pausing traffic during congestion. So something like jumbo frames on some ports improve throughput for data heavy applications like backups or video streaming. It increases security. Port security can limit the number of MAC addresses, preventing unauthorized devices. So it will disable unused ports to block physical access points into the network. And then it also supports specialized devices, so like VLAN assignments on per port basis, which keeps critical traffic, let's say control systems, separate from general traffic. It controls redundancy and failover, so it uses STP, which is spanning tree protocol. Port priority decides which port becomes the active forwarding path in a loop topology. What is port priority? Port priority is a setting on a switch port that helps determine which port will be chosen to forward traffic in a spanning tree protocol or STP topology. STP prevents loops in a network by blocking some paths and allowing others to forward traffic. And when multiple ports could forward traffic, STP uses port priority to decide which port should be preferred. And what is lower port priority? Well, that's a higher chance of being selected as the forwarding port. And then there's higher port priority, which is less preferred, more likely to be blocked. An example of port priority, imagine a switch with two paths to the root switch. So port 1 has a priority of 128. Port 2 has a priority of 64. So STP will prefer port 2 for forwarding traffic because 64 is obviously less than 128, and only block port 1 if a loop would occur. So the key uses for port priority, you can control redundancy, so you can decide which links should handle traffic in a failover scenario. You can optimize your network performance, so it ensures the fastest or most reliable path, and you can prevent loops predictably. So this gives admins deterministic control over STP decisions instead of leaving it to a default calculation. So you want to think of it like lane priority and a highway interchange. So the lower numbered lane, which is the lower priority value, gets to handle traffic first, while others act as backup. Now let's go into Maple Link Lite and let's look at the port settings configuration and also the port priority configuration. So to find this, go over to the left side, configuration, port settings, and then let's look at the configuration tab here. So you can choose between 1 to 8 ports because I'm using the MS1L08G, which is the 8-port Lite Managed switch. So in the port configuration, you can enable or disable the port. So if the port is disabled, it will remain inactive and perform no operations. So to keep the port functioning, you want to set this to an enable state. And then speed specifies the speed in duplex mode at which the port should operate. So the available speeds are 10, 100, and 1000 megabytes per second. And then you can also choose the duplex mode, half duplex, or full duplex. So a half duplex system provides for communication in both directions, but only one direction at a time, not simultaneously. Once a party begins receiving a signal, it must wait for the transmitter to stop transmitting before replying. Then a full duplex or double duplex allows communication in both directions simultaneously. Landline telephone networks are an example of a full duplex communication, as both parties can speak and be heard at the same time. Back in Maple Link Lite, under the speed/duplex, you can also choose auto, which is auto negotiation. So when auto negotiation is enabled, when you select auto, the switch port and the peer device exchange information to agree on the best common settings. So if the peer device does not support auto negotiation or has it disabled, the switch port will attempt to detect the speed based on the signal, but will default to half duplex mode. When auto negotiation is disabled on the switch port, it will use the manually configured speed and duplex settings. In that case, you must ensure the peer device is manually set to the same speed and duplex mode, or the connection may fail or perform poorly. There is also auto MDI and auto MDIX. Now, these settings you cannot manually adjust. They are automatic settings within the light managed switch. Now, auto MDI or MDIX is a computer networking feature that automatically detects the type of Ethernet cable needed, straight through or crossover, and it adjusts the connection accordingly. This eliminates the need for crossover cables when connecting devices like switches to each other or establishing peer-to-peer PC connections. You can also turn flow control on and off. Flow control is a high concentration of traffic on a port, and it can reduce bandwidth and overflow for the port's buffer memory, resulting in a packet drop and frame loss. Now, it's specifically called IEEE 802.3x flow control, and it's used in full duplex mode by sending a pause signal to the transmitting port when the receiving port's buffer becomes full. This temporarily halts transmission until the buffer has space again, and it allows data to be resent later. Now let's set some of our port settings. So let's choose a range here, say 3 to 5. Want to enable these, and maybe want to set this to 1000 megabytes per second at a full duplex, and then hit apply. And you can see those settings are saved here to, let's say 6 to 8, and enable those, but we want to set these to, let's say 100 at a half duplex, hit apply, and it saves those settings here as well. Now let's go to the priority tab for port priority. So to explain port priority a little better, typically networks operate on a best effort delivery basis. So meaning all traffic is treated equally and has the same chance of being delivered in a timely manner. So during periods of congestion, all traffic is equally likely to be dropped. The port priority feature allows to prioritize specific types of network traffic based on their importance. By implementing port priority, you can make network performances more predictable and improve overall bandwidth utilization. Port priority uses something called 802.1p priority. So you can select a priority level for packets that are received on the port. This priority will only be applied to packets that do not already have an 802.1p priority tag. So to understand what 802.1p priority is, so it's a way to mark how important a message, which is an Ethernet frame, as it moves through a network switch. So you want to think of it like priority stickers on packages. So the high priority sticker gets delivered first, the normal sticker gets delivered when possible, and the low priority sticker waits until others are done. So this helps switches decide which data to send first when the network is busy. Here is a table for the typical 802.1p priority mapping in industrial automation. So this is how the priority is typically set up for an industrial automation factory or plant. So over on the left, you have your PCP priority, 7 being critical, all the way down to 0, which is typically your general network traffic. So 7 could be your routing protocol messages, network management traffic, so that's your highest priority and must not be delayed. Very close beneath that is your very high 6 level mission critical automation, PLC to PLC messages, PLC to HMI control. So like emergency stops and halts that must arrive quickly to avoid production issues. Then you have in the high realm, you have your time sensitive video and your voice, so like IP camera video streaming, security, monitoring, operator intercom over IP, emergency calls for voice. So streaming video needs smooth delivery and voice needs very low latency. For medium, you have your SCADA polling, event logging, data collected for monitoring, logging, reporting. That can tolerate some minor delays, so that would be in the medium range. Then your low, 2-in-1, engineering access. So laptops used for engineering, large file transfers, firmware updates, scheduled backups. That's not time critical, so that's a lower priority. And then at 0, you have your general network traffic. So that's like web browsing, emails, that's standard default priority. So this is the typical priority mapping for an industrial automation plant. Now, an industrial automation plant could have different levels of priority, but this is just an example. So how does this work with a switch? So the switch looks at that PCP number in the tag. It puts the frame into the matching priority queue, and then the high priority queues are sent first when the link is busy. So 802.1p makes sure important traffic gets through the network first, so voice, video, or control data don't get delayed by less important traffic. So after explaining all that, you can now see that you would just choose these based on that number system. So let's say you want port 1 to be the highest priority, set that to, let's say 7, and then maybe you want to set ports 2, 3, 4, and 5 to a lower priority. So maybe you set this one to 4, this one to 3, and then maybe you set this one to 2, and so on. And then you would apply that, and that's how you would set your port priority. Well, that wraps up everything today. To get more information, you can visit the How to Configure Port Settings and Port Priority to Improve Traffic Management tutorial page, and also check out the Light Manage Operations Manual to get more information on Maple Link Lite. Lastly, make sure to visit the Industrial Network Switches page, and this can all be located on the Maple Systems website. I hope you enjoyed this video, and thank you for watching.